Hi, I'm Cameron Evans, and welcome to this episode of Engineered, where we're going to talk about lubricants. I've had a really lucky career in that I've been able to do most of the jobs out there in the racing and performance industry you could, from getting to race cars and motorcycles to magazine editor for a long time. And through being a magazine editor, I got to know Tim Kerrigan, the president of Redline Oil, went to work for him and ended up running the company. And my road here at Redline's been pretty fun and pretty interesting because I've gotten to learn more about engineering on a lot of different levels. It's actually possible to make stuff at the very highest end without compromise. Hopefully we're going to dispel a few more myths about things like what motor oil is made of, what types of gear oils are out there, what friction modifiers are, what slipperiness really does for you, and whether or not fuel additives really work. We get the question a lot why oil is important, but it's really more than just motor oil, which is the first thing that people think of. It's actually manual transmission fluids or automatic transmission fluids. It's differential fluids as well, but it's kind of easiest to explain when you look at motor oil. Number one, cooling. That you may think of your radiator, that's the job to cool stuff off, but really the motor oil does almost as much of the job. When you think of trapping contaminants, oil over 10,000 miles, it's there to trap contaminants for that entire time while it's cooling the vehicle off. So the way motor oil base stocks are classified is actually by the API, the American Petroleum Institute. They've got it in 5 different groups. Group 1 and 2 are crude oil based. There's the petroleum base stocks that you bought for $3 or $5 a quart. The next level up is a Group 3, a hydrocrack version of that, more refined. So when we talk about refining, we talk about using pressure and temperature. We talk about a lot of separation, separating off the waxes and really getting to the parts of crude oil that could make for the best raw materials. Those Group 3s are actually getting a lot better these days too, and that's why a lot of the OEs use them as a prime base stock to keep the cost of motor oil down. Where synthetics really get going is in Group 4, polyalpha olefin, and they take off to even more performance in most of what Redline does, which is Group 5, ester-based products. And that will provide you with unbelievable opportunities to throw temperature at it, and basically it's as good as you could put in the bottle. So one thing that we look at when it comes to the difference between petroleum oil and synthetic oil is think about the range that a petroleum oil would work within. So if it's cold over here and hot over here, it actually is going to get really thin and get really thick depending on where it is. Synthetic products actually work within a much thinner range, and maybe a Group 3 might work out here. This really does represent the overall stability of the product when associated with temperature. When you think about which one of these groups do I put in my car, it really depends on cost. Now, a Group 1 or a Group 2, petroleum-based product, you're probably not going to take that to a track day. You're probably not going to stick that in your M3, right? A lot of what you're trying to find, let's say from a Group 3, is a medium price point that you can start doing longer drain intervals. Then when you start to understand the science of motor oil, you'll start to see that you probably aren't going to start wanting to stack big-time drain intervals, 10,000, 15,000 miles, unless it's probably a Group 4 and up. People have a lot of questions about the actual naming culture of the motor oil weights. 5W30. What does the 5 mean? What does the 30 mean? The 5 is the winter weight. So basically that's the viscosity of the oil when you start your car. The 30 would be the operating temperature. So you may be asking, what's a 030? What's a 530? And what's a 1030? The 030 is what you're looking for in Minnesota. So if it's 30 below out, that oil will stay thin enough to be able to safely start your car. If you live in Florida, you don't necessarily need that. A 1030 that doesn't need to get that thin in cold weather because it's not cold outside, that's the proper weight for you. That 30 would be the same whether you're in Minnesota, whether you're in pretty moderate temperatures, or you're down in the heat of Florida. So remember that a 30 weight viscosity has the same centistokes. At 100 Celsius, it's got the same thickness no matter whether you had a 530, a 030, or a 1030. Where I run into this a lot is guys at track day cars where they're trying to figure out what oil to run. At that point, it doesn't matter because they're probably not going to operate the car at anything less than, let's say, 45 or 50 degrees Fahrenheit. So the oil's not going to know the difference. When it's running around the racetrack, it's going to know that it's a 30 weight. When you start running better motor oils, for example, if you've got something that's a PAO or an ester compared to, let's say, a Group 1 or a Group 2, a lot of times that factory oil weight, the 5W30 that might have been recommended for that car, will actually go to a track day and not have a problem. We have a lot of Redline customers that are putting 40 weight in their car when they could have stayed at 30 weight. Now, how do they tell that the oil's too thick? It's usually with the oil temperature. If you've got a vehicle that's got an oil temperature gauge, if you've got any ability with data acquisition, you may see that it takes a long time to build oil temp, and then once it's got oil temp, it won't get rid of it. The case of this is the 10W60s we see that are running a lot of M3s. It takes forever for them to get to 200 Fahrenheit, and then once they start building oil temp, they're at 270, 280, 290. That's when we recommend to a lot of our customers to move away from a 60 weight down to a 50 weight. Some of them even go as far down as a 40 weight. Something you want to consider when you start making decisions to change your viscosity is, do I have variable valve timing? Do I have camshafts that move? So take BMWs, for example. They've got a Vanos system that runs on oil pressure that we've never seen a Vanos system in a lot of these popular cars like in the E36s and the E46s that would run on less than a 40 weight on a track day. So just remember that the oil that's protecting a lot of different things and performing a lot of different functions, you can't go real light if you're having to make sure that Vanos is continue to work. So when you start thinking about oil temperature, that basically the trash can starts to come off of motor oil at about, let's say, 200 degrees Fahrenheit. And as we're operating this oil, we want to get this up to, let's say, 212 degrees Fahrenheit. As we get much further than that, the oil is going to get thinner. But at least if we got past 200, it's got the trash lid off the oil, right? We can now start trapping contaminants. This is a very safe zone to operate in. As you get up to, let's say, 240 degrees, this is actually an okay place to run as well, but just realize that your 30 weight is no longer a 30 weight anymore. Your 30 weight's got a little less viscosity than it did because that 212 degrees or 100 C is where the zone we're actually trying to operate motor oil. That's where 30 weight is the viscosity of a 30 weight at that design temperature. The first thing to remember about what happens to oil when it gets hot is what type of oil are you using. Conventional oil or petroleum-based oil is going to start out pretty thick and it's going to get pretty thin if you throw wild temperature swings at it. Synthetics are far more stable. When we mean stable, if you get them really cold, they don't get as thick. When you get them really hot, they don't get as thin. That's what makes synthetics perfect for performance customers, whether you go to a track day, whether you go to the drag strip. Volatility is a term we use in the motor oil business that is a big association with heat and what happens to your motor oil. So imagine getting a cheap motor oil, a Group 1 or a Group 2, so hot that it starts to evaporate off the raw materials that made it the viscosity you wanted in the first place. You don't experience that so much when you talk about PAOs and esters, but actually some of the newer motor oils that are Group 3s that the OEs are recommending for some of the performance cars, some of those Group 3s are pretty volatile. That's why we're recommending for a lot of cars that are going to better motor oils for track days, for performance activity, make sure you do it if you're going to get this thing hot. On the topic of friction modifiers, remember that these are additives that make motor oil more slick, not less slick. A lot of people get that confused. When it comes to motor oil, friction modifiers are fantastic. They take away not only some of the wear we would see in the engine, but it's actually what's making things slick, makes the engine more efficient. When we talk about automatic transmissions, they're also important because it's really easy with so much heat to create wear in that transmission. ATFs these days are generally slick. What's also slick are GL5 gear oils, the gear oils that are designated for the differential in your vehicle. There, we're trying to take care of limited slip differentials where we're trying to split the torque between the left and right wheels. What'll happen is if the gear oil is not slick enough, you'll get chatter within those discs. Remember that if you have like a Torsen limited slip differential, one of these mechanical types, it actually doesn't operate on friction. It's mechanical. The limited slip friction modifier in a gear oil that you might use, it's actually not bad for that ring and pinion. It keeps the temperature down. So just remember, a friction modified gear oil, it's not so bad with a mechanical. It's necessary when you have a clutch type clutch pack that you're trying to keep from chattering. Where we don't want to find any type of slipperiness, or at least limited slipperiness, is in the manual transmission. So that's where GL4 oils are used by definition. A lot of people that use Redline might be using MTL or MT90 in that application. Synchronizers within that transmission, we're trying to slow them down. The synchronizers are on this cluster and they're trying to basically help you get from one gear to the next. They've got little teeth, they've also got grooves. If we can slow that operation down, we can slow them down enough where they can make a mesh and you don't get gear clash in the box. So when we look at the topic of high mileage motors, the first thing you want to ask is, I see high mileage motor oil on the market, does that work? Yeah, it actually does work, but it really depends on the application you're trying to use it in. If it's a daily driver that's got 200,000 miles and it's leaving a bunch of oil in the driveway, then those type of motor oils actually promote seal swell, so you can take up a few gaps and leave a few less drips behind. They actually do what's intended. Now, if you had a high mileage motor and you were trying to do a track car, you bought an old car that you're trying to go run Chump or Lemons with, that's not where you use high mileage motor oils. That's a case, like we spoke about earlier, where you'd want to take, if it was suited for a 40 weight, you might move to a 50 weight. So remember that the types of applications you're dealing with depend on whether you'd use a high mileage type motor oil or you'd use the regular synthetics or something that you're trying to run and go up one viscosity. Now, we deal with a lot of old race cars, chump cars and stuff like that around here. A lot of guys that work here in Redline and people we work with race these cars a lot. We get BMWs with 190,000 miles on them. We go race them. What's the first thing we do? We get the cheapest conventional oil we can and we start flushing these engines. The only safe way to do it. We'll run them for a half hour at different types of load and actually push a lot of the contaminants into the motor oil. I've actually done as many as 4 oil changes within a couple of hours, turning the motor oil black, turning the motor oil black. And we're trying to pull some of that stuff out. But what might happen is we pull some of that sludge out of the engine, it might start leaking. Because think about it, a lot of sludge that was built up in that engine might have been sealing up a bad gasket that we didn't even know about. Same thing goes in differentials. You switch to good synthetics, you might sweep away where a little bit of sludge or buildup was, and it might expose an old cork or paper gasket. So remember, don't blame synthetics for leaking. Back in the day, yeah, there were problems. There was ester products that maybe weren't properly matched to just a bit of PAO to promote that natural seal swell. These days, the idea of synthetics leaking out everywhere, that's over, that's gone. Where it's not gone is where you might actually sweep away a contaminant and expose a bad gasket. There's some snake oil out there and there's actually some fuel additives that work really well. One thing that I know doesn't work very well is octane booster, but we'll get to that in a second. So when you think about it, solvent-based fuel additives, they really probably don't have much detergency in them. You're not going to see a big result. Detergent-based fuel additives, you're guaranteed to see a result if you had contamination that you're trying to get rid of. Perfect example, we use pickup trucks quite a bit around here. That imagine 100,000 miles on a Chevy truck or on a Ford truck, there's quite a bit of carbon if it hasn't had very good fuel in it. that could get built up in the combustion chamber, get built up on the pistons, get built up inside fuel injectors. So when you run a really good bottle of fuel cleaner, you should be able to see a full mile per gallon better, let's say, in mileage improvement than if you hadn't run one at all. That mileage improvement should continue in the next couple tanks of gas because you've basically started to return the condition of the vehicle back to what the OE wanted. If you run something that's solvent-based, it may not have the kind of intensity that would actually clear out any kind of carbon from the engine. So when we're trying to get rid of carbon inside an engine, if you take the combustion chamber, right, and you've got, let's say, valves here, and then you take the piston, which might have a little bit of a dome to it, it's not a very good drawing, but at least it's got a skirt, that this overall area that we're trying to simulate, get back to the OE equivalent. Remember that the original equipment manufacturer designed to compress this much air and fuel in one area. Well, if we've got it filled up with carbon, then that means basically we've turned our 9-to-1 engine into a 10-to-1 engine or a 9.5-to-1 engine. We're trying to get this engine back to original equipment specifications. That's where fuel additives remove carbon and get the thing back to its original performing capability. One point I want to make is that the fuel that's on the market now that you get at the pump, if you buy a top-tier fuel, if you're constantly buying good fuel from the time the vehicle's new, that the treatment of that fuel with detergent is actually pretty good, that you'll get an OE level quality of cleanliness throughout the life of that vehicle. The best recommendation that we make around here is that if you use a fuel additive, check it on the odometer, check what the mileage is. There is absolutely no doubt that you can control the wear in an engine with better motor oil. It seems like such a simple question, but really when you look at the price point from some of the more simple petroleum conventional-based oils up to the top-line synthetic oils, the difference you would see from the beginning of an engine's life to the end of its life is significant.